Bismillahirrahmanirrahim. Today we will learn about NumPy. First of all, we will look what is NumPy. NumPy is a fundamental package for scientific computing in Python. Basically, it is a Python library that provides a multidimensional array objects, various derived objects such as masked arrays and matrices, and an assortment of the routines for fast operations on array means multiple routines of the fast operations on arrays, including mathematical logical operations, shape manipulation, sorting, selecting IO, discrete Fourier transforms, basic linear algebra, basic statistical operations, and random simulations. Why we use the NumPy? In Python, we have lists that serve the purpose of arrays, but they are slow to process. NumPy aims to provide an array object that is up to 50 times faster than the traditional Python lists. The array object is NumPy is called an array. It provides a lot of the supporting functions that makes working with an array very easy. Arrays are very frequently used in data sciences where speed and resources are very important. So it is this is the purpose why we use the NumPy in the computer sciences programming. Why is NumPy faster than the lists? As traditionally we use the list, NumPy arrays are stored at one continuous place in memory, unlike the lists. So processes can access and manipulate them very efficiently. This behavior is called the locality of the reference in computer sciences. Means they take the reference, basically NumPy take the reference of the arrays. So it is very important in the computer science. This is the main reason why NumPy is faster than the lists. Also, it is optimized to work with the latest CPU architectures. So this is a little introduction of the NumPy. We have seen that what is NumPy, why we use NumPy, so why they are faster than the lists. Now we will look how can we use NumPy in Python. For that purpose, we will use the VS Code. I have opened the VS Code. Here I'm creating a new file. First of all, I will save the file, giving it a NumPy practice. So we will install, first of all, we will install the libraries like pandas, pip install pandas, right? Then we will install the NumPy. Same %pip install NumPy. Then we will import the both libraries. Import pandas as pd, then import NumPy as np. So this is the way how can we install and import the libraries. We will run it. The system is working on it. Okay, now we will create the arrays. We will have different methods to create the array. For that purpose, we are having a variable. We can take any kind of the variable. Array r is equal to np dot array parenthesis and then the square bracket. I will write the numbers, pass the values 1 2 3 4, and then call the array or print the array. So here are the result, array 1 2 3 4. Okay, here is another method. Array is equal to np dot array, then double parenthesis. I'm going to pass the same numbers or any other number like this. Now we will print the array, right? So here are the results of this array. Then okay, now we will look what are the dimensions in arrays. A dimension in array is one level of the array depth. Means what are the nested arrays level. So first of all, we have the 0D means zero dimensional. Zero dimensional array return us a single value. For example, ar is equal to np dot array and then we'll print this array. So it returns us the single value. Then we have one dimensional array. One dimensional array is the simple array as we have created before over here. It has all the elements of zero dimensional array. We will use the function np dot array, and then we have the values. For example, I'm going to write these values, right? And then we will check the result. So here is the one dimensional array. Then we have the two dimensional array. Two dimensional array has one dimensional array as its element. Means we have two arrays like this. 15 comma, then we will define the second one, print the array. Sorry, we will have parenthesis, then square bracket, and then the another bracket, because it is the two-dimensional array. When we have the three-dimensional array, we will see that we are having three brackets, like array is equal to np dot array parenthesis square bracket, then again square bracket, and then again square bracket. Now we will show the numbers. We will enter the numbers. Comma, again square bracket, so okay. So here are the results of the three-dimensional array. So we have basically we have practiced the four-dimensional arrays. One is a 0, then one dimensional, two-dimensional, and the three-dimensional. Okay, if we want to check the dimension of the array, we will have the option. We will write the same code. First of all, we will define the arrays. A is equal to np dot array and the value. The second, b is equal to np dot array is equal to, then c is equal to np dot array parenthesis, because it is two-dimensional array, d is equal to right. Then now we will store the arrays. Print a dot n dem, then print b dot n dem, then print c dot n dem. And dem basically is the function to show the number of to show the dimensions of the array. Print d dot n dem. So here a is the 0-dimensional, b is the 1-dimensional, c is the 2-dimensional, and d is the 3-dimensional array. We can also check the shape of the array. For that purpose, we will define the array. First of all, array dot np, I have these elements in the array. Then we will use the print array function. Print, then array dot shape. When we run this code, we will have the answer 133, means the three-dimensional array, and it has all has 3 elements, right? We can also reshape the arrays. For reshaping arrays, we can convert a single array into many arrays. For that purpose, we will use the following functions. First of all, define the array. Is equal to np dot array, and I'm going to have these functions. 3, 6, 7, and then 8 numbers. I'm going to convert this array into two arrays, reshape this array into two arrays. For that purpose, I'm going to define it in a new array. New array is equal to array dot reshape. Now we will define the order. I want to have two arrays with 3 values. Now print the new array. Okay, I have 9 values in an array, and I have reshaped this one array into 3 arrays, 3-dimensional arrays with 3 elements in each array, right? The same way, first is the order, means the number of the arrays, number of the dimensions, and second value is the number of elements which an array have. If I want to have um, 2 elements array, then I'm going to use this function. I am having 12 elements, and I want to reshape them into the following order. New array is equal to ar.reshape 2, 3, and 2. Now we will print this new array. So we are having 2 arrays, 2-dimensional arrays with. Now we will use another function. To convert the multiple dimensional arrays into 1-dimensional array. For that purpose, we are using the technique of the flattening of the array. We will use the following method. We are having an array of 2 dimensions, and for example, ar is equal to np dot array, defining we have 2-dimensional array, then new array is equal to ar dot reshape shape and -1. Here -1 will convert the multiple dimensional array into one dimensional array. So here it is converted into the one dimensional array. Okay, now we will look what is array indexing. Array indexing means if we want to have the information of the element, then we will locate the uh, number or the value in the array. For that purpose, for example, we are having an array of these numbers. 4, and I want to locate the index 0, print array index we will mention the index and then run. So it will return us the value 0. If we want to locate the fourth element, we will use the same pattern, but here we will write the third element, because array started with a 0 and then run. So here is the fourth element of the array. So here we can index the elements. In the same way, we can add the numbers of the array. We can add the values of the array. For example, I am having the array values 12, 13, 14, 15 and 16. Okay. Now I want to add the numbers of the after indexing. For that purpose, I'm going to use array. For example, I want to add the third element, which is for that I'm going to use a 2 plus again index, now the fifth element. So the third element is 14 and fourth element is 16. Fifth element, sorry, is the 16. See, then 14, it gives us the result 30. We can also index the two-dimensional arrays. For example, I have this two-dimensional array. Two-dimensional array, and now I want to show the second element show second element of first of first row. Second element of the first row. So 0 is the first array and then the first element. So second element of first row is 2. So here is the 2. So in this way you can you can index the numbers of the two-dimensional array as well as the three-dimensional array. Now I want to we have three-dimensional arrays. As you can see, I want to show I want this element. For that purpose I will print the value third element of the second row. For that purpose array 0 and then the second array and the third element. Now we will run it. So here is the answer, which is 6. Now the array slicing. Okay, now we will do the array slicing. What is array slicing? Array slicing means if we want to get some specific number, we want to show some specific elements from the array, we can use the array slicing technique. For that purpose we are going to have an array which is I have shown this like array dot np dot array. I have mentioned the elements of the array. Now we will print some chunk, some slice of the array square bracket, and now the area or the number which we want to show, I want to show from 2 to 5 number elements. Run. Okay, we have at number 2 means the number 3 because it is going to be started from the 0. So 9 till 8, 2 to 5, 9, 7 and 8. So third to fifth element is going to be shown over here. If we want to show the number till end, we will use this function. First of all define the array. Right, like this. Now I want to print the number from third element to the last one, right? I'm not going to mention the last number, just the columns, and leave it as it is. Run the graph. Here is the result from third element to the last element. So in this way we can have the number of the elements if we want to show them till the end of the array. Okay, if we want to show the number from end to the backward side, so we will use the following negative slicing. Array is equal to np dot array one. Okay, now print the array. Square bracket. Okay, I want to show -3 to -1. So -3 to -1 means the 7th and the 8th number, means fourth, from 4th to 5th number. So in this way we can use the negative slicing. Okay, we can also join two or more arrays. For that purpose we use the concatenate function. I'm going to have two arrays. Array 1 is 1 2 3. Array 2 7. Now I want to join these two arrays. Print dot concatenate we will store these two arrays in another array where we use on np dot concatenate function. Array 1 and array 2. Then we print that array. We have used np.concatenate function. In parentheses we have written the name of the arrays, and then we will print the new array. So here is 1 2 3 4 5 6 means the joining of both arrays. We can also join the two-dimensional arrays, but the only thing which is different when we call the array, we have to mention the axis as well. Storing of array np dot concatenate array 1 dot array 2 and comma axis is equal to 1. Now print the array. So here is the combination of the two-dimensional arrays over here. It is also the two-dimensional array, but joining of two different arrays. We can also sort arrays. Sorting mean the arrangement of the elements. If we have the array like this, I want to sort the values. For that purpose, don't dot sort function is going to be used. Sorry, np dot sort function is going to be used. Np dot sort function is going to be used. So here the values are arranged in the ascending order. So here is another array. Name of the fruits. Now I want to print the array after sorting. So here the alphabetical order can be seen. Apple is the first element, and bananas, then grapes, and then mangoes. So this is the way to sort the arrays. Okay, now we will have the filtering of the arrays. Filtering of the arrays means if we want to filter an element or number of the elements from the arrays, we can use this technique. I have an array which is equal to np dot array. Right, now I'm going to define a variable x which has another array. Now we have the values in the x, true, false. So there are some true values and there are some false values. Now we will store this x in the new array, which is new array is equal to np. So we will store the array x into that new array. We will print the new array. And here are the true values, like 42 and 44 are the true values. This is called the filtering. Okay, if we want to show the values more than 42 in the previous array, so we will follow the following steps. We will create an empty array, filter underscore array, and we remain this an empty array. After that we will apply apply the for loop for elements in array. If element is greater than 42, then then filter array value dot append will be true. Else it will be false. Now we will store this filter array function in a new array. For that new array, we will write like this: new array is equal to array filter array, and now we will print this new array. So in this way we can show the number more than 42. So this is called the filtering of the arrays. Hope you have learned something regarding NumPy. Thank you.